triangle, remember, it doesn't have to be perfect. We're just getting an idea of what a triangle looks like. After you do this, you just label A, B, and C. Little a, little b, little c. Angle C is 82, 60, little b is 5. Okay? After I label this out, I go back and I write down now, what are the three things I have to find? Well, I have to find angle B, I have to find little a, and little c. I always make a list of what I need to find off the side first. Always, always, always do that, okay? Easiest thing here to find then is, in fact, angle B, because that's what it's forcing you to find first. So you take 82 and 60, I believe that's 142, sound about right? Subtract that from 180 and it gives you 38. So I have a 38 here, I just write it here, so I keep tabs of it. Now, since I have an angle and the side opposite, remember how I said circle it, or oval it in this case? When you do that, then you use the same setup to find both side A and side C. So you'll have the sine of 38 is to 5, as the sine of 60 is to little a. Sine of 38 is to 5, as sine of 82 is to little c. Okay? Now, when you have these algebra, notice the variables in the same spot for both of them. So the setups and the work-throughs are going to be the same no matter what. Hi, good morning. Thanks. When you go from here, we're going to multiply by 5 and change the a. So you get 5 sine 60 over sine 38 will be a. 5 sine 82 over sine 38 will give us little c. And then express a whole bunch of buttons. Yeah. All right. What else can we look at? It is pretty bad. I hope so. That's why, like I said, I thought about pushing through a video and showing you guys how to do all this stuff yesterday, but then realized that's a lot of work involved in that. So not like on my end, but it's very. I hate when it's so dry that you have to explain so much, but it's easier to show you guys why it works if I'm actually just physically here doing it. So, okay. What about book work? You good on those?
Yeah.
No.
I saw the Coyotes video.
Nice. What? I'm going to do that today because we're going to go. That's all we're working with. We're going to work with those, and we're going to work with law and cosines. Law and cosines is ridiculously simple. It's very straightforward to go through that as well. What do you want? Do you want to take her now? She's annoying. Well, I didn't say that. Did I?
Yeah, you did.
Go. Ah. All right, skill check it. We got about 6 minutes to spare, and we got things to do. Everybody pay for your Use your homework, it's fine. Hey, I feel like it doesn't change the grade if you know what you're doing. If you know what you're doing, it doesn't change because you get all the points. Yeah, you kind of need a calculator. I don't know if you knew that. I don't know if you figured that out. You kind of have to have a calculator to make any of this stuff work, otherwise it's just all sorts of bad. Alright. Yeah, oh yeah.
Actually, so I don't like it.
Alright, we got 6 minutes. I want these all done before 8 o'clock. We got things to do. Places to go, people to see. Tuesday we briefly talked about the idea of how in law of science, what happens is that you get this possibility of having a secondary triangle with possible angles and sides. The reason that this works is, if you guys remember last year in geometry, you did the quick little computer lab on the Chromebooks about how you match up the sides and angles to see how they were congruent. Sometimes that side angle worked, sometimes it didn't. And it was always dependent upon one little quick idea. And what happens here is, like we talked about last week, if you get the angle side, if the angle that you're given is obtuse, don't worry about it. You're not going to have two triangles because you can't have more than one obtuse angle. The other thing is that if the side opposite, remember how we caught that one where the side opposite the biggest angle was smaller than the other side? Then you knew that wasn't a triangle. It wasn't able to work. You saw that on the worksheet the other day. When you were given the side and side, even those were acute angles, as soon as you did the math on it, it was saying invalid domain, it wasn't going to work. All you had to do then was just double check it, make sure you didn't do something stupid, and then you realized there was no triangle possible. Now, the main thing of this whole idea when you had the angle side stuff is, textbook-wise, they show you all of these different 6 possible scenarios to go through. What a giant pain in the butt to do any of that. That is such a waste of time. That's why I told you guys on Tuesday, when you looked at the, I think what would we use, 40 degrees? So if you looked at 40 degrees, and then we moved this 40 degree over to here, so it was up 40 degrees as well. Anytime you move up from the x-axis the same amount, it's called a reference angle. Reference angles are reference angles are always going to be how far you are bounced off of an x-axis, all right? So reference angles are up or reference angles are down. They're always positive, okay? This is up 40. If I moved one to here, it'd be down 40, okay? We're going to do a lot of those next week.
Wait, what?
I know. What? I can't hear you. Anyway, so the idea was that this 40-degree angle also shared the same sine value as the 140-degree angle, okay? Because they were horizontally across one another as it reflected to the second quadrant. That's the idea about bouncing. When I say bounce it to the second quadrant, that's why we check it that way. So, for example, if I have one like this where we have angle side, we have an angle of 20, the side of 10, and the side of 11. So if we do our generic setup, C, 20, little a is 10, little c is 11, okay, and then we have little b. So first thing I always do is I label the parts that I know that I need to find. In this example, we have to find angle C, angle B, and little b, excuse me. So angle C, angle B, and little b. Hopefully, when you guys do that, it's helping you to realize that there's things you don't forget, okay? It's just a little trick, all right? Now, from here, what is this problem forcing us to find first? C, what? So we circle, okay? And I'm going to set up this by C. So I have the sine of 20 is 210, as the sine of C is 211. What do I have to do to get to the C by itself? All I have to do is multiply by the 11. Are we okay with that? Was the mathing of this, the ratios working really fast, I'm hoping, for you guys now? Yeah. Okay. So this becomes 11 sine 20 over 10 is the sine of C. Let me get my calculator open here. You're in degree mode. Always, always, always. Thinking. So what did I say it was? Sine 20? Come on. 11 sine 20 over 10. And then to this I have to inverse sine it, so second sine of my answer, and I hit enter. It gives me 2.1 when I round to 2 decimal places. Are we okay with that? Okay. So here's where I was getting at the other day. It gives us an angle C of 22.1 for C. All right. Now, since our original angle that we started with was a cube, now I'm going to check, find the supplement of 22.1. The supplement of 22.1 will be 180 minus the 22.1. So we get 0.975, 157.9. Okay. So that's the supplement of 22.1. Both those angles here and here have the same sine value. They have the same y coordinate when they place in the grid. Now, what I do is I take my original angle. What was our original angle A? 20. So what I'm doing is I'm checking. Angle A was 20. I add it to this, I get 177.9. Is that above or below 180? Below 180. That's why we get two triangles. Okay? If that number is below 180 degrees, that means you have two possible triangles. So what you do now is this. I'm going to call this one the supplement we had. This was angle C. This is going to be the other possible angle C. We call it C prime. Okay. All right. So now what I do is I draw another triangle. Okay. Yes. I draw another triangle. So we have this. Let's do this a second so I can make this a little cleaner. So as of right now, we have side C or angle C here at 22.1 for the first triangle. So I put that here, 22.1. I know that I still have to figure out angle B out of this, so I take 22.1 and 20 gives me 42.1. Subtract that from 180, it gives me 137.9, I believe. Okay, so that gives me 137.9, oops, for angle B. So then I have to use, it does this, 137.9. So I can use law of sines again to find this side B for the first triangle we're working with, and then we'll go back and redo the second one. So we have sine of 20 is to 10, as the sine of 137.9 is to little b. Multiply by 10, divide by the sine of 20, it'll give you your b. So 10 sine 137.9 divided by sine of 20, was that right?
Yeah.
Thank you. And it gives me 19.6 for little b. Okay. So 19.6. So if I look at this first triangle, obviously decimals and all that, it's very difficult to see what's going on. Does the biggest angle have the longest side length opposite? Yes. Does the smallest angle have the smallest angle? That means you're probably on the right track. Okay. You've solved the first triangle, so now you know that you're going to have a second triangle. What you do is just redraw the original triangle. A doesn't change, little a doesn't change. This is now a C prime because you found a new C angle, which means B will be a different angle, so we call it B prime. This little c doesn't change because it's the same value here, and this will be little b prime. Okay? Your original information doesn't change. It's just that when you set it up, this is still 20, this is still 10, this is still 11. Now C, yes ma'am? Remember how we checked to see if this supplement had enough degrees to add it to the original to make a triangle? That's why it changes. Oh, the little c? Because it'll still work. Because when you figure all this out, this angle B is just going to be a lot smaller.
It's like your original information.
Yeah, the original information stays the same. The A's and the little c stays the same because that's the original. What we're saying is that if you think about it, when you have the triangle here, this side length and this angle doesn't change. When it goes to here, what changes is all this side lengths here. Okay. So here we get, what was it, first 157.9. So now we find angle B prime. We know that it's 77.9. When you add those two together, subtract that out, what do you get? 2.1. So B prime is 2.1, so we have B prime. So now I use law of sines again. Sine of 20 is to 10, as the sine of 2.1 is to little b. It is so much easier to do it this way by just checking that supplement than it is to do all those multiple steps. Doing all those multiple steps is a pain. Yes, ma'am.
So if it's bigger than 180.
You're done. You only have one triangle. That's the little shortcut trick thing that I've been using for years. All right. When you do that, you get what? 10 sine 2.1. 10 sine 2.1 divided by sine of 20, and you get 1.07. And again, if you look at it, does the biggest angle have the longest side length? Does the smallest angle have the smallest side length? If that's yes, you're on the right track. That's all there is to this. I mean, it sounds like, it is ugly. I'm not gonna lie, it's ugly, but the trick is check that secondary quadrant to see if it works, and if it works, go. Yeah. Yes. Yep, because when I found the original C angle, I checked the supplement. If this supplement plus the original angle of 20 is less than 180, that means I can have two triangles. Okay? All right, let's look at another one. I think I got another one on here. Yo.
Does this only work when you have the angle side to side?
Yes. Yep. You only have to check this with angle side to side. I could make you do this with log cosines as well, but I kind of steered away from making ambiguous cases out of log cosines because it gets really messy. All right. So like I said, when you go through these things, we use if you have side-side angle or angle side-side, if your given angle is obtuse, you just check to see if the side opposite is bigger than the other. If that's okay, you know your triangle's going to work. If it's acute, if the angle that you're given is acute, the first thing you're going to do is find that next angle, check its supplement against the original. So I was saying in here. And if it's less, those two angles add up to be less than 180, ta-da! You have two triangles. Okay? All right, let's try another one. I think I have one more here. Yeah, this one, I think this one works. Again, I have angle side side. So 70, 155, and 160. What is this forcing me to find first? Angle B, yeah. It's forcing me to find B, so we have to find B, C, and little c. So sine 70, 155, sine B, 60. Move it around, we get 160 sine and I get 75.93. Oops, sorry. I add that to 70. I'm sorry, get the supplement of that first. The supplement of 75.93 is going to be what, 104.07? That would be called B prime. I add that to 70. Am I under 180? I have two triangles. That's all I gotta do. And then you just do it all, reset it. Okay? And then just you solve for the rest of the triangles. Just redraw the secondary triangle and go from there. And I know law of science, as you guys have been mentioning, is relatively quick. That's all you have to check that angle, just bounce it. It's fast. It's so fast. If it doesn't work, you know you don't have to do it. Okay? Now, law of cosines, though, and again, law of cosines is something you guys did last year. This is the same idea that you use law of cosines when law of sines doesn't work. Okay? Law of cosines is when you have side angle side or side side side. All right? There's three versions of writing out law of cosines. I don't ever want you guys to memorize all of it. It's kind of stupid. if you look at what's happening with the log cosines, I have them up on the board there. Notice how it's little a squared, and at the very end it's big A. Little b squared, and at the end it's big B. Little c squared, big C. And notice how the other two parts are the same for each one of them. All you're looking at, oh, sorry, that should have been, I just realized it should have been BC. I just looked at that and I realized I wrote that wrong. 2BC cosine A. So what happens here is when you're using the law of cosines, just looking at it in terms of you've got your angle and the side opposite are always going to be the tails. The stuff in the middle is the other two sides squared minus 2 times those two sides, cosine of whatever the big angle is for the other side. Okay? It works really, really fast. All you have to worry about with these guys, oops, this was the second one. All you have to worry about with these things is always find, if you have side, 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 find the biggest angle first. That usually will take away the possibility of an ambiguous case. So, but I'll just say if you start with if you have to start with the law of cosines, you do not need to check ambiguous. Does that seem fair? If you have law of sines, you always got to check it. But I won't make you have to do that again with law of cosines, because law of cosines gets messy sometimes. Again, in this case here, what we want to do is just draw a quick picture. A, B, C, little a, little b, C. 38, 12, 16. That is side, angle, side. Okay. That means I know my angle, I need to find my side. So I got to find the little b. So I started out b squared. Well, that'll be a squared plus c squared minus 2 times a times c times the cosine of big B. And when you have side angle side, you'll be very pleased to know that you just type it in exactly the way you see it. You take the square root. It's really fast. Okay? So if I do that, let's see, clear all this out. 12 squared plus 16 squared minus 2 times 12 times 16 cosine 38. I get b squared is 97.4 something and change. Second square root of my answer. I get b is 9.87. Do you now have an angle and a side opposite? Use law of sines to find the rest. Okay. You only have to use law of cosines once. Once you get an angle and a side opposite, always go to law of sines, it's faster. Okay. It'll always be faster. Again, it's just pressing a lot of buttons. All right, it's a lot. Cosines, especially if you're just trying to find the side. When you got to find the angle, there's a little bit of weirdness if you're not careful. You just got to remember it's a two-step equation as you go through it. All right, let's try one like that real quick. Yeah. So this is one where you have side, side, side. And again, I know you guys did this last year, so that's why I'm kind of breezing through cosines. Little a, 8, little b, 18, little c, 13. Which angle is it forcing you to find first? Or which one should you find first? B. Always find the biggest angle first because it will run you less of a risk of something screwing up. Okay. So when you do that, set it up with your b squared, 18 is a squared, 8 plus 13 squared minus 2 times 8 times 13 times the cosine b. Now I'll walk through you with this one as far as how you type this in. First of all, do you guys agree that you have to move both the 8 squared and the 13 squared to the left? Okay. So what we do is this. We start by typing in 18 squared. Oh, jeez. Start by typing in the 18 squared. And then we have to subtract, I forgot the other two numbers, 8 and 13. So 8 squared minus 13 squared and hit enter. Write that number down. 91 equals negative 2 times 8 times 13 cosine This is just some number multiplied out, isn't it? Okay. So now in my calculator, all I have to do, since I have the 91, I'm going to do a 91 fraction bar, -2 times 8 times 13. Because I have to divide by all of that. Don't forget the negative there. And then hit enter. -7/16 equals the cosine of some angle, so how do you find the angle? Inverse, yep. Second cosine of the angle. Notice it was negative. Cosine comes first in the alphabet, doesn't it? Cosine and sine. What comes first in the alphabet? X or Y? X. So if it's 115 in that second quadrant, isn't X negative in the second quadrant? So you have your angle B at 115.94. And then what would you use? What angle would you find next? Yeah, go with the next, work your way down. Always work your way down when you're doing law of sines after that. Just boom. Use that, find C, and then find A, and you should, hopefully those three angles add up to 180. You should be within rounding error, and what I mean by rounding error, it's like a tenth or two. If you're plus or minus like 6, you screw something up. When you're doing these things, guys, don't round as you're going through the problem. Let the calculator do the work. Okay? Let the calculator do the work and it'll be all right. It's not bad, was it? I'm trying to remember. Draw that picture.
Okay.
Wait a minute. Twenty feet apart. 20 feet apart. Below the surface of the water. Okay. They see a shark below them, and the pressure one of them is this and one is that. Okay, wait.
And then you walk
20
there,
feet
like,
apart, so that looks kind of like your bottom.
yeah.
Or like your finger side of the feet. And each angle starts your two bottom angles are 47. I don't know what I don't think it matters which one is what. No, it doesn't matter. So it's just an angle, 40, 60.
And like, I know I was keeping them. I'm doing this, keep your more efficient method, and we're not gonna do weird, like.
So if we drew this somewhat decently right, here's kind of what I'm thinking. You've got the water. You got two guys that are 20 feet below. They're start directly across from one another. 20 feet apart below the surface. So they're 20 feet apart here. So here's our 20. Okay. Angle of depression, line of sight looking down from one of them. 47. The other one is 40. Okay. How far away is the shark? So where's the shark? The shark is.
Oh my God.
That's why they put sharks up, sharks up, shark like.
If you kind of move it, it looks like
So
it looks like a food.
now think about it. This is angle side angle. So what are you going to use? Law of sines, law of cosines. You're trying to figure out these two distances here and here. Okay. Relatively straightforward.
Yeah.
What I have for you, I did not get a chance to talk about what's called Heron's formula. We'll talk about that briefly tomorrow, and then we'll get into more of this style of the work problem with drawing pictures and things, law of sines, law of cosines. In the textbook, it's 13.6. I want you guys to do numbers 30 through 37. Okay? What they are is they are a mixture. They could be starting with law of sines. They could be starting with law of cosines. They could have ambiguous signs. They could be a right triangle. Each one of those is independent of each other. Draw the picture and go from there. Okay? It should be pretty quick. All right? I know we kind of bum rushed that, but it didn't seem like you guys were too off with the sine stuff. So. Does that make sense though about the whole balancing thing? It's the easiest thing to think of, and like I said, it's one of those things that textbooks don't talk about. It just works. So I don't know why we don't do it. Plus, then again, you guys have to do unit circles. That's the other reason why it sounds good. Oh, unit circle. And don't forget, next Tuesday will be our last day of using calculators for a while. Because we like that.
But like, elementary school, like math is like so weird. I
know. What they try to do, they try to show us the algorithms for people. Not every kid learns the same way, so they're trying to figure out all these different possibilities. So maybe one kid learns the one way versus another.
So